You're given this piecewise function, and in that definition there is this unknown value a. The question is, what is the value of a for the above function to be continuous? Now remember, piecewise functions have different definitions given by the conditions. So when x is less than -1, so here's -1, it follows this parabola. Let's see, that's a parabola that's like this, so it does something like this, okay? And then after -1, it follows this, and I have no idea how to draw this because we don't have the value of a. But I mean, imagine this is a line, right? So you might have some line like this. Then if these two don't match, what happens? Then there's a jump discontinuity between them, right? So this is exactly not what I want. I really want the value of the right side equal to the value of the left side. Now if you recall the definition of the continuity of a function, to be continuous at -1, by the way, -1 is the only point that we're worried about, right? Because these are separately polynomials. Polynomials are always continuous, so if this function is not continuous, it's going to happen at -1. So we just have to make sure that at -1 this is connected. Now the definition of continuity is limit of x goes to a of f of x equals to the value of f at a. So for that to be true, you need the left side to exist, the right side to exist, and they have to be equal, right? And since we're really worried about the jump discontinuity, it's really about whether this exists or not. So we want left limit equals to the right limit, because then it wouldn't be a jump discontinuity, and then everything else will just work out because the value already exists, and once you make it connected, then the value and the limit should equal. So let's try to write down this condition. Let's see what that means. So limit of x approaching to -1 from the left, so you put a minus sign, of this function f of x should equal to the limit as x goes to -1 from the right side, so I put a plus sign there, plus of f of x. Now the left limit, well, this is when x is less than -1, so you're trying to follow this, so you should be using this. So the left limit is computed by limit as x goes to -1 minus, and then x squared minus 5x. And in this case, there's no problem with just plugging this value in. So -1 goes here, -1 squared is +1, -1 times -5 is +5, so you end up with a 6. On the other hand, this one here, since x is bigger than -1, we're using this definition, so we should send x to -1 plus, and then ax plus 8 is the definition we're using, and then you plug in -1, you get -a plus 8. Okay, so now that we want these two to be equal, we bring those two together and say 6 should equal to -a plus 8, and guess what? I think 2 satisfies this, right? If -2 plus 8 is 6, so a is equal to 2, so that's the answer. So that was pretty quick, right? Okay, let me do another question that's similar. You have another function which is defined as different values, but you know, the function value exists except that the value might not be the same thing as the limit. So in this case, we first have to make sure that these two give you the same limit as x gets closer and closer to 2, and then this value itself should also equal to that one. So all of these 3 should equal when x is equal to 2. So first, for the left limit to equal to the right limit, well, the limit as x goes to 2 from the left is really this 5x over x plus 4 evaluated at 2 minus, right? Because you're trying to evaluate this at 2 minus. That limit has to equal to this limit, x squared minus x plus a, when x is evaluated at 2 plus. Okay. Now this means evaluated at. Often you would make this. Often you would make this one written as, let's see, x equals to 2 minus, x equals to 2 plus, just to emphasize the fact that you're plugging these numbers into x. Okay, but this is I believe this is a new symbol. I've never shown you this before, but this is a very handy notation. You have this function, you're plugging in the value into that function, okay? You have this function, you're plugging in this value into the function. Now if you do that, then you have 2 times 5, which is 10, 2 plus 4, which is 6. That has to equal to, when you plug in 2, that's 4. When you plug in 2, that's minus 2, plus a. So, well, this simplifies to 5 over 3. Whereas 4 minus 2 is 2 plus a, so a must be 5 over 3 minus 2, which is negative 1/3. Okay? Now, so this condition number 1 makes sure that the limit does exist, right? The left limit and the right limit do agree, and therefore the limit does exist. But the entire condition for a function to be continuous at x equals to 2 is that the value has to equal to this. So number 2, the condition is, we already know that this limit is, when you plug in this to 2, they both should agree to get you this value 5 over 3. So I know that this should give you 5 over 3. And because f of 2 value is b, now I have that b should be 5 over 3. So the answer for this is that a should be negative 1/3 and b should be 5 over 3.